Okay, my friends, so let's smash together this last final step, visualizing the decision tree regression results in high resolution. All right, so we're going to do kind of the same exercise as what we did previously with the SVR. You know, that funny exercise where we start from the polynomial regression code for the visualization of the results, meaning this one. So we're going to start from this code, and then the exercise for you will be to make the right change or changes in order to make this work for the decision tree regression model. If we did this successfully for the SVR model, well, it will be a piece of cake to do it for the decision tree regression model, because indeed no feature scaling was needed, and therefore we won't have to play with the transform method or the inverse transform method, and therefore you will just smash this. Okay, so let's do this. That's the exercise. So let's take this whole code here, which plots indeed the regression curve in high resolution, but for the polynomial regression model, let's paste that right here in the new code cell. And now, well, there you go. Please press pause on the video and make the right change or right changes in order to make it work for our decision tree regression model. Okay, good. So now I'm going to implement the solution with you, and let's start with the obvious change. Let's replace polynomial here by, well, decision tree. Okay, and then what was the change or changes you had to make? Well, as I told you here, it's super easy. You just have to change two things in actually only one row, which is row number 4, right? Because this row number 3 is totally fine, because here X and Y are on the right scale, because no feature scaling was applied, so that's fine. And here, well, the obvious change that we have to make is, of course, to first replace this regressor by the right name of the regressor, which is regressor. All right, good, regressor. And then here, remember this polyreg transformation object was used to transform the matrix of single feature into this matrix of the same feature at different powers, power 2, 3, and 4. And this time here, we absolutely don't need that because we're not doing polynomial regression. So I'm removing this, and then also a parenthesis here. And now, guess what? Well, that's done, right? That's the simple visualization code when you don't have to apply feature scaling and you don't have to transform your matrix of features into powered features as in polynomial regression. So that was as simple as that, I told you, right? But now that was the good news, and now I have some bad news. You're going to see that the results are not going to be pretty, because indeed, let's do this now. Let's execute this cell. There you go, playing, and here are the decision tree regression results. I really want to say this again. The decision tree regression model is really not the best adapted to two-dimensional datasets, with only one feature and one dependent variable. But once again, I'd like to remind that the implementation we have here can be very easily adapted to any other datasets, and I will show you what to do at the end of this tutorial, what to change in this code. But I still wanted to show you the decision tree regression results in 2D. And so why isn't this pretty? Because what this decision tree regression model simply did was to take the real results, the real salary for each position level, and then for all the position levels from position level minus 0.5 and the position level plus 0.5, well, it predicted the salary to be the same as the position level in the middle. All right, so that's what it simply did, and that's, understandable and intuitive, to understand, because how decision trees work. They work by splitting the data through successive nodes, and so at the end, you get different ranges of the features where the prediction is the same. And so here, all the predicted salaries in this range of position levels are just the same, and that's why we have this stair-looking like curve up to the last position level. And of course, here, this is not continuous. This is actually a vertical bar. So the regression curve here is not continuous. We jump from position level to the next one every step of one. Okay, so not pretty at all, not relevant at all in 2D, but I still recommend to try the decision tree regression model for higher dimensional datasets, because indeed, it can actually have great performance. All right, great. So congratulations. Now you added this new machine learning model in your toolkit. And now we will tackle together the final regression model of this part 2. And until then, enjoy machine learning.